Good morning, good afternoon, and good evening, wherever you are. Welcome to another CIQ webinar. My name is Zane Hamilton, and I'm the Vice President of Sales Engineering at CIQ. We here at CIQ are focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source. Today, we're going to be talking about RPMs and how to create them. So if we could bring in Skip and Jonathan. There he is. Excellent. Welcome back, Skip. Good to see you.
Thank you. Nice to see you.
So again, as always. Jonathan.
Hey, Jonathan. How you doing?
Yeah.
Tell us about who you are.
Good to be here. Thanks.
Thanks. Perfect. Skip, it's been a while. Why don't you remind everyone who you are and what you do?
My name is Skip Gruby. I started out as, and still am, a Rocky Linux core SIG or release engineering contributor. And in short terms, it means I build a lot of packages, and especially when package builds go wrong, I'm often there to check them out. And I'm also a Linux engineer and kind of engineer at large at CIQ as well.
Excellent. Thank you, Skip. So I know we talked quite a bit last night about RPMs and
yes,
how to build them. And it seems to be the common, we've talked about.
Oh boy.
Quite a bit of stuff. And I haven't done this in a long time, but I was looking back through some old code that I put together last night after we had our conversation. And I actually had comments in my code of this is painful and I don't ever want to do this again. So how have things changed? How is this different now?
So I too remember the bad old days. The tool that we still use at its very core is RPM build. However, there's a lot more to it now, and we're gonna talk about an interesting wrapper around it called mock. It's kind of a simple idea, but it's very powerful, surprisingly powerful. And I know, like you, I remember, RPM build, and you had to get everything just right, and you had to say a few magic words, a few cuss words, and then set your directories properly, set your macros, and then maybe it would work, right? And then it would work, but maybe it wouldn't work for somebody else, and that's no good. And mock, it kind of gets rid of that idea. It's very nice. So what we do now, instead of saying Zane's going to build his RPM on his system or Jonathan's going to build his RPM on his system, what mock does is it will create a siege root or container. It does both. But the idea is to spin up very quickly a very minimal Rocky Linux or other Linux system within your current box, right? And then run the build inside that minimal system using just things that are available in there. The build can't see anything else. And produce the results, collect the logs, and you're done. And it sounds simple, it sounds stupid, but it's actually way easier than setting up RPM build and doing all of this stuff yourself. And we're going to demo it. We're going to show off, we're going to do a little build of our own. And I think one of the first things I need to talk about when I talk about RPM packages is where do they come from exactly? Because a lot of people don't, when you do your DNF install or whatever under your Linux box, if you're still using your yum command, I understand. Love that. Muscle memory. The RPMs effectively are compiled from source RPMs. Source RPMs come from code. Effectively, there's three components to a source RPM. We have usually a zip file or tarball of some kind with source code in it. So we're going to talk about Bash. We're actually going to compile the Bash shell that everybody knows and loves. Well, most of us love. And
if you don't, you're wrong.
So inside, and we're gonna demo it if you don't mind right now. Can I present here? Can I share my screen?
Certainly.
Because it's easier to show you than to tell you about this. So share screen. I'm gonna click on this one. And here I've got a Rocky VM running, but we're not going to use that just yet. We are going to move this over. And we're actually going to go to one of my most visited sites, the raw Rocky Linux download pages. And I just happen to know, so You can browse these. These are also added automatically in your DNF config files. You can go to etsy-yum.repos.d. Show you that in a minute. But we're going to go into here and just Rocky Linux, just like just about every Linux, distributes source packages with their binaries, right? So there are, let's see here. So, bash. This is the bash source package. And we're going to look at it real quick because I just want to show people. So there's 3 components to a source RPM. There's a spec file, looks like this. Bring it over here. It's a recipe for doing a build, right? It's got, the name, the version, things that it depends on, make it bigger for everybody. We're not going to get deep into this right now, though. It's a little complicated. There's a lot of documentation about it, but this is just a how do we build this? What commands do we run? Whether it's a make and a GCC or whether it's a Python thing or whatever, right? And it's got requirements here that we need in order to build this, things that it provides, things that the package requires, that sort of stuff. And it's got, you'll see Bash has quite a few of them. It has the second component of a source RPM is patches. And you'll see these are all the patches. Most of these are issued by Red Hat because our upstream provider is Red Hat from our code. And this is just stuff that is added on to the main Bash source code that are oftentimes they're backports. They fix little bugs, security issues. Maybe they change behavior to a way that's more conducive to enterprise Linux, whatever. Right. And then the final component is, as I said, the zip file or the tarball. And that's in here. And this is literally, if you go to, I think it's Savannah. Is it GNU Savannah? I'm not sure the upstream. It's actually probably in here. You look at source 0. Aha. So this is where the upstream source was gotten from. So if you go to GNU's FTP server to this location, right, this base version, our base version's 5.1, it's this file, right, and you can book it. They should match exactly, and that's all we need to compile our bash. So
Skip, if you don't have the source file, will it pull it down from that URL automatically?
It will not. No,
okay.
It has to be bundled. So the source RPM, it's expected to be able to compile without any internet access, right? So we want to make sure that we have everything bundled together within our source RPM. Right. And once we have the source RPM, it's really, as we see here, kind of demystified it. It's just a bunch of source code and a spec file as a recipe to, how to build that source code. And we're going to take it and we're going to build it. And I will show that, I think, right now. Is that okay with you guys?
Absolutely.
A little practical. Awesome.
Absolutely.
Let's go.
Excited.
Let's go. All right. First thing we need is a Rocky Linux system. Doesn't necessarily have to be a Rocky Linux system, but as a member of the Rocky Linux team, you can imagine I have a bunch of VMs. I've got a bunch of all kinds of things going on, ready to go. So got my thing running. We're actually going to load up a terminal and SSH into it because it's going to be easier than using the VM screen, but that's the one we're going to be using. And let's see if it lets me in here. Excellent. Okay. And the first thing we're going to do, this is very easy. I think we're going to use 4 commands here to set up our mock. And the first one, many people likely have already done this, is dnf install epl release. Spell it right, Skip. And epl, for those that are not familiar, is an excellent collection. It's a third-party repository. It stands for Extra Packages for Enterprise Linux. Has a bunch of stuff, including this mock program that we're about to install. But it's another repository maintained by the Fedora project. Has a bunch of extra packages, extra stuff you might find interesting, compiled for Rocky Linux or Red Hat Enterprise Linux. And now that we have our epl powers enabled, we can dnf install mock. Very, like I said, 4 letters, very simple package here. It's written in Python, so there's going to be a few Python dependencies. But as you'll see here, it's actually quite small, surprisingly small for what it does. This package is, less than 200 kilobytes here, and it's got some support stuff that it needs to install. So we're going to do that. Go. Terrible time for any mirrors or anything to to fail on us.
Normal, right?
Yeah, that would be That's Murphy's Law in action there. Okay, cool. So now we've got mock here. We're just going to, I'm not in the mock group. Excellent. So we're going to do that too. So we don't want to run mock as root. I mean, you can, but I don't want to on the system. It's not how I work in general. You can run it as a normal user. You should. Users in the mock group are allowed to run mock builds. So what we're going to do is we are going to add Skip, that's me, to the mock group here. Very simple. This is and then we're going to relog in because we want group membership to be updated. And I will check, and we see, aha, now I'm a mock user. I have build powers. Awesome. And the next thing we're going to do is we're going to scroll back over to our vaunted bash RPM, source RPM that we saw earlier. We're going to grab it here, and you guys can read this. I don't know how visible that is, but
no, it's good.
It's
good.
Go check it out. And we're gonna download. Let's go. Good old wget. There we go. Now we've got a source file. I'm gonna create a temporary folder to work in here just because I don't want to clutter anything up with logs. And now we have our source RPM. We've got our mock build component, right, or our mock build program. Very simple. I'm going to time the build. Time is a command that I do it all the time for my builds because I enjoy seeing how fast a system works, how fast compilation happens. It's very useful to, well, for a lot of reasons, but especially during builds, very useful for benchmarking and so forth. Verbose. We like verbose. And let's see, I'm going to say resulter is home skip temp. There we go. That's the current directory. And then we're just going to say, hey, that source RPM, home skip dash RPM. Awesome. And I'm going to press enter and go. And we're going to, while this is happening, it's going to take a few minutes. We're going to talk about what's going on here. So, and then we'll pause for some questions for some discussion because I don't want to talk forever, of course. What's happening here is the mock program is actually creating a very minimal Rocky Linux system right in my virtual machine here inside a chroot. It's actually a container environment, and it's installing. You'll see there's some packages here that are really the bare minimum of things you need to get going. Like, just so you can have just so you can run DNF to install more packages effectively. And once that step's done, and it's going to complete soon here, this is going to look very familiar to anybody who's ever installed packages before. Then we're going to check out, it's going to read that bash spec file that we looked at over here. And it's going to say, hey, what are the requirements that I need in order to build this package, right? And then it's going to install those packages, but only those packages, nothing else. And then it will proceed to read this, it will proceed to call RPM build just like you would, but inside this minimal system and perform a build. And that way we're doing it in a place that only has the bare minimum needed to build bash and no extras, no optionals. Hopefully that makes sense.
I have questions about this small environment.
Yes.
The environment. Tell me more about this. You said earlier chroot or a container. How does this work? What is it doing underneath? Is it really a container platform? Is there something else I've got to do?
Yeah, so there's two options in mock. The default, which we're using right now, is called systemd inspawn container. You can read all kinds of technical, wonderful details about that. It's a systemd feature that effectively allows you to create containers, not with your traditional Docker or Podman or whatever. It's actually systemd will talk directly to the kernel, to C groups, and create a container for you with storage and networking and everything. And it's very nice because this program, you could use Docker to run RPM build, but we don't want that overhead, right? We don't need a whole Docker install to do this. And we're interested in just spinning up the bare minimum environment, and then we're going to discard it at the end of this. Like, this is all, once we have our build and our resulting RPMs, then we don't care anymore. Like, we just, the environment discarded, and we'll wait for the next time we call for a package, spin up a new environment. And so yeah, we keep things clean. There is also an option if you don't like, in fact, it's actually very popular, is originally systemd inspawn is kind of a newer in enterprise Linux terms, a newer thing, you can run it with just a simple chroot, right? Where no containers at all, just good old, chroot developed in the 1980s, still around, wonderful tool, and it will do the same thing. The technical details are a little different, right? The container and the chroot inside it, they can see different aspects of the kernel. Sometimes that when you get to advanced builds, that will affect things occasionally. But here for Bash, it's a pretty simple package, so we're just going to we're just using the default.
Okay, and then whenever it lays this down, we're talking about being clean and simple. Does it actually clean this up for you when it's finished, or is that something else you've got to take care of after the fact? Does the environment
Yeah,
go
so
away?
by default it cleans it up, but you can. There's actually, again, if you get into mock building, I encourage you to check out all the options because there's a million of them, and you can say, especially for troubleshooting, hey, when you're done, do not clean this up, right? Go, leave the directories lying around so that if something went wrong, we can actually go into the chroot and check out, like, what was going on, like what kind of files were produced, right? If there was an error or a file that was missed or something, we can explore that. And while this is happening, I know there's a lot of scary text there, but it's this is what happens when you compile Bash. If you'd like, I can show that. We can, because it's it's pretty straightforward, which again is why I like this tool. Like no mystery. So all this is, in fact, I'm going to become root for this because I believe I need to be root to explore this. When you installed mock, there's a mock here, and we'll see there's a couple of folders. We're going to go into the mock config. Your configuration for mock sets this. We'll go into that in a minute. And you can see here's root, and aha, this is, if you look at my system here, I'm inside here, but this looks like a root directory. This is where Bash is being built, even as we speak. And I'll bet if we go into builder here, we can, yep, there's all kinds of stuff going on inside this wonderful little lib directory in here. And so we can, if we wanted to, we could explore the GCC, what it's pulling as it happens. I'm not going to get into that right now, but yeah, this is the chroot, or it's the container in this case. Don't want to mix up my terms, but yeah. So if you want to explore it, there's a mock there. There's an option to mock. I think it's called -- no clean, something like that. Don't quote me. And it'll say, hey, mock, do not remove this stuff whenever you're done, right? Keep it around, keep it intact so that Skip or whoever can look at it because something went wrong. Sorry, I get my tea.
No, it's all good.
I need build tea.
Build tea.
Skip, we've talked a little bit about the benefit of kind of listing all of your build requirements in that spec file. How normal is it for some of the packages that come as this minimal base system to be omitted from that list or specified? Does the package make assumptions about that base system and only define requirements that would go on top of it?
That's an excellent question. And yeah, so you're what you're talking about, the initial set of packages, that was that first DNF command that was run inside our mock thing. That is what we call a build root. So, and it's there to basically bootstrap a real minimal Rocky system. And you're absolutely right. You're touching on your requirements and the trying to put this in a good way, but your RPM build requirements are only as sound as how minimal your build root is. Because if you throw, say, Java into your build root, which is a terrible idea, don't do that. And your RPM actually requires Java, but does not specify that, then yeah, it will have Java, and there'll be a problem because somebody who doesn't have Java, and it's not a requirement, will experience issues, right? And it's a hard question to answer. I think the defaults for mock are pretty darn good, is all I would say. They are about as minimal as you can get and still have a functioning system. It's really, if you take stuff away, and it's really, if you, let's look at our log here and I'll show you what I'm talking about, because oh, look at that, done. Bash RPM, and I always love to test my RPMs So let's do something kind of dangerous here. Let's take this new RPM that I just compiled and overwrite. We're gonna just we're gonna remove the current bash, which I'm actually running right now, and install the one we just produced, and it should be just fine because I think it's the same version. Installing, yep, awesome, yep. And so now we are running, strictly speaking, even though they're identical, we have bash installed from the one we just built. We just built our own shell interpreter. Fantastic. So yeah, back to your question. So let's check out really when the system begins, and I'm going to make this a little prettier here. Root.log, by the way, is the is Mock's setup process for creating the container, right? This is the stuff that it needs to install before compilation is actually done. Go down here, we see that this is the list of packages here, right? And really, there's not a whole lot of you can't really take much out of here and still have something that's going to work, if that makes any sense. And so I think you could add on to it if you're interested in that. But again, careful. So I think every RPM package, no matter what, should expect these to be present. Like as a you can still specify them. You can say, hey, I need grep or I need gzip. It's good practice, right? But I think it's safe to say that just about every system you're going to encounter is going to have this stuff and its dependencies, which you can see here, installed. Hope that answers the question properly. I don't know if I'm wandering here.
Yeah, maybe the point of reference is I don't think I've ever seen, for example, a package say that it depends on or build depends on glibc. And is it acceptable in that case to have there be just things you don't have to say in your spec file?
It really depends on what system you're building for. So like Rocky Linux packages, they come from, we have a tightly controlled system that's based entirely on Red Hat Enterprise Linux. And if you are running Red Hat Enterprise Linux, you are running glibc, right?
Mhm.
There's no ifs, ands, or buts. And so it's not normally specified. However, I can imagine a situation via container or via something else crazy where you have an RPM based distribution that maybe has musil libc or something, and that would need to be specified within your package, right? So it might be a good practice in that case to it really depends on your RPM's intended audience, I guess,
Mhm.
intended build distro, because they're very different.
Sure.
If that makes any sense.
Yeah, thanks.
So we're very fortunate in Rocky Linux. We have, again, Red Hat Enterprise Linux, great product. We have a very high quality upstream. There's still problems because when you build, 3,000 plus packages to build a distro, it's not trivial. There's all kinds of weird things that can crop up and need debugging. But in general, for most run-of-the-mill packages like this one, they're pretty solid. So do we have any other questions? Looks like we built it. I'm going to go off on a little tangent here because we were talking about other distros, and it's important to note if you're not familiar with Mock or this process. Mock is a Fedora tool, and it's used a lot across the spectrum, right? This is not just a Rocky Linux thing. So if you go into /etc/mock configuration directory, very interesting here. There are a lot, as you can see, of distros. And the power of this tool is that, remember, when we create a chroot and begin our build process in there, it doesn't have, this is a Rocky 9 system. We just built Rocky 9 bash, but it doesn't have to be that way. We could specify, hey, we want to build, CentOS 7 and take, a bash design for that and build that, right? And we could do it right here on this system, or a Fedora one, or an OpenSUSE one, or whatever. It's the only limitation is that you have to have be an RPM based distro.
Yeah, there are a lot in there.
Yes, there
Very
are.
cool.
There's an awful lot of derivatives and distributions and all kinds of things. And I think we'll explore a little bit. So you'll see the one that I was using is the default. is Rocky 9. It's default on this system because they kind of assume that if the packagers of mock say, hey, you're using Rocky 9, you probably want to build Rocky 9 packages, which is a fair assumption. And you'll see this is really just a Python config file here. It's a bit of Python code. If you're familiar with it, this is a Python dictionary. And it's really cool how the settings, that's how the settings are set. And let's check out this template file because this is the real interesting one here. And we'll show you kind of behind the curtain here with mock. This is very interesting. If you've ever edited Yum or DNF config files, you will be familiar with this, right? And it's fascinating because you have to remember when you're building an RPM package, it's the location that you grab its dependencies from matters a lot. Like, it's hugely important. And so it's really cool because in mock you can manipulate this to be whatever you want it to be, right? So right now, like, yeah, this is pretty default, but you can point this, you can change the DNF priorities to say, hey, I want my own repository that I hold on to I want you to get your GCC or your dependencies or whatever from there first, and you can manipulate the versions that you're building against, right? So let's say common, I wouldn't say common, but issues we have building sometimes where, like, hey, this Ruby package will not build because new OpenSSL breaks it. So let's build it against a slightly older OpenSSL at build time so that it compiles correctly, right? There's all kinds of fun things you can do to inject your own dependencies, to change your build route. There's the sky's the limit here because you can literally, this is you customizing your system that you build or that you build your RPM on. So very cool stuff, but easy to edit too. Like, it's literally just some text.
So what's the process like for creating a new one of these, Skip?
Oh boy. So it's really not bad. I'll give you an example here. And when you say new one, you mean a new config file, right?
Well, a new config file, but also, like, you and the team just put out a whole new distro in a sense of Rocky 9. And
yes.
Not only is there not a config file for it, but there's also not repositories for it to draw
Yes.
from.
And it's true, you have to start somewhere, right? And there's several ways to do it. Fortunately for us, because Rocky by its nature is a downstream distribution, we have excellent upstreams in Red Hat Enterprise Linux 9 and CentOS 9 Stream further upstream. And so what we've done to get started is we have bootstrapped Rocky Linux 9 off of Red Hat 9 beta, right, which was released, oh gosh, I want to say it was like December last year, January this year. And you can see, I'll kind of show it off here because I'm heavily involved in this. I have a web server that was kind of the project allows me to use here. And we'll look at the Arch 64 here. This is, remember, by the way, in real life Rocky Linux land, we have to do this for, I think, 5 different architectures. We compile for the ARM processors like Raspberry Pi. We compile for 32-bit. I'll explain that in a minute. We compile for Intel 64-bit. This is your default, laptop, desktop server processors. S390X, which is the IBM mainframe System Z processors, and PowerPC, which is another IBM derived processor line. And so all of these are generally they're fine, right? They're very consistent, but occasionally we'll have a problem where, oh gosh, there's it compiles for everything but S390X, and we have to figure out exactly why. And there's a lot to that, but yeah, you see, this repository here is huge. There's like, I think, 8,000 plus packages in this repository, and this was, hey, Skip needs to go through and begin effectively a complete rebuild of what's in Red Hat Enterprise Linux 9 and some of CentOS 9 Stream in order for us as a build team to get going. And so, yeah, this is how we start. we effectively, download source code, put together source RPMs, and begin this mock process over and over and over again. And there's tools and automation to help us, right? So it's not like I'm just sitting here, you know, can't by candlelight, pressing, oh gosh, I'm gonna build this and then build this and 3,000 more times or whatever. No, it's we have tools to make the machine do the work. But yeah, it's a lot of effort though, and it's a lot of time. But so you see, and these are free to browse. You can see how Rocky Linux 9 was bootstrapped, and it's pretty crazy. I hope you have a lot of memory in your web browser because these are some big listings.
So once you say bootstrap, once you have that set of packages that you get from
Yep.
somewhere, and you
Let's
you
talk about
build
the.
you build Rocky Linux packages against them, do you then go back and rebuild all the
Yes,
Rocky Linux
sir.
packages?
Yes. So
Yeah.
this is only, you'll notice here, this directory, stage 1, right? It's there's more, and that brings us into Peridot, which I think we'll talk about just briefly. Let's go ahead and load it up. This is a public site, peridot.build.resf.org. I'll put it in the chat here, and if anybody wants to paste it up, you can. It's very, like I said, public site. Anybody can browse this. Not everybody can import and build stuff, but everyone can browse it, right? And let's just check out Rocky Linux 9. See how we're doing here. And let's go into builds. We're going to pick out a couple recent ones here. And we'll see. Node.js. Hey, that's a cool one, right? Everybody's favorite JavaScript server. I'll be honest, I don't understand it very much, but that's.
Yeah, so some people seem to like it a lot.
All right, so, and you can see here in this, there's a bunch of tasks that happen, and these are the interesting ones here. It says build for x86, build for i686. These are the different architectures that we're building for. And if you hang on, the build is rather long, so we got to get all the way up here. Give me a second, I got to scroll. Having trouble scrolling here. I don't know what's up with my browser.
It knows people are watching.
I guess so. Let's go back. Let's pick another one here. Yeah, let's see. Hey, bind, everybody's favorite DNS server. All right. New version of bind. Okay. And if we go up here. Boy, this is a lot. All the way to the top here. Usually I click home for this, but I'm not sure why that's not working right now. There we go. Okay. And you'll see here, you'll notice that this text looks awfully familiar, right? And that is because when this Peridot, which is our build system, I guess GUI, it's a lot of things, API, GUI, import and build system. All it does, and Koji, which is the Fedora CentOS build system, all they do, they are very organized, elaborate ways of calling mock and RPM build, right? And so like this text out here is almost identical to what we were just doing in our, if I can go back into my build directory here, you'll see a little clearer here. See here, like this text here, like we compile, or we install a bunch of initial packages, then we install a bunch of packages that the RPM we're building requires, and then it executes RPM build, just like we just did, right? And so this is an excellent way of doing local testing or local builds. And if you set your mock config correctly, you can make it completely compatible with what the real Rocky Linux project, or even the real CentOS or Red Hat Enterprise Linux project are doing. And I see that question there.
Yeah, got a question.
Mock, can you cross compile? No, and I'll explain why. RPM in general does not natively support cross compiling. You can, but the logic to do it has got to be built into the spec file. I've seen ones, there's some QEMU ones in particular that are like this, but there's really most packages are not going to bother doing that because they assume that if you want to perform a cross compilation, you have access or are able to, you know, you're able to have a system that also has that compiler. And if for bootstrapping initial systems, it gets, I'm not, this is kind of beyond the scope of this talk, but it gets into like, well, you're gonna have to cross compile things manually enough to get RPM and some basic packages going. Now, let's say that if you completely new processor architecture comes out and we have to build software for it, right? There's going to be some more fundamental work before you can get to RPM land. And so, the goal should be really when we begin we begin porting or a system for this, the goal is to get enough stuff to get to this build route, right? This initial set of packages that we have inside of mock. Once we have that, we can get rolling. We can say, okay, well, we'll build, you know, we'll build very slowly, I guess, some basic packages, get our C compiler going, et cetera, right? So there's a that's a very not going to get into that process. Very deep, very complicated. But the short answer is no.
What about
And
i686 packages on an x86 64 system?
yes, so that is fine.
Okay.
Mostly, and same ditto goes for the ditto for if you think about ARM64. You can compile as long as the processor supports it. So we know x86 64 processors, Intel processors, support 32-bit mode. Not all of them, but many ARM64 processors are also backwards compatible with ARM32 in the same way. And yes, because what we do, and we can, let's check it out here. Actually, let's look at the i686 build.
Presumably, you'll still need like a 32-bit bootstrap or environment to build against, but other than
yes, and that makes the whole difference, right? Because as long as you have some RPM macros, which mock does for you, set to the proper processor architecture, and then you have a proper build route and build environment that supports it, then you're golden, right? And we can look up here, way up here, and I'm not sure. Normally, I just press home and it takes me to the top of the log. I'm not sure what's going on today, but of
Too many
course,
video streams at the exact same time.
must be. Here we go. So yeah, you'll notice that when we're installing here, this entire little system we're installed is all i686. There's no 64-bit stuff going on here, right? And that's because, well, it's 32-bit packages do not need 64-bit packages. In fact, they actively don't want them in order to build. So, and going beyond that a little bit, because I can sense your next question, which is, it's story time for me. The why build 32-bit packages? Because Rocky Linux and Red Hat Enterprise Linux does not release a 32-bit version.
My question was actually, where is my 32-bit ISO?
Yep. So I can read your mind. And the answer to that, the reason that we build 32-bit packages is because if you look at your Rocky Linux repositories and Red Hat upstream Red Hat repositories, there are certain packages like OpenSSL, several others that they include 32-bit variants bundled in. So if you want the 32-bit version for whatever reason, you can install that. And they're for compatibility's sake for various, a lot of commercial software. They might, distribute a 32-bit version still, God knows why, and they need 32-bit OpenSSL or whatever to work, right? And the Rocky team in the beginning said, "Oh, sure, this is going to be fine, right? We're just going to compile, these, 20 32-bit packages, right? We'll compile OpenSSL 32-bit. Oh, look, to compile OpenSSL 32-bit, we need these 3 other packages. Okay, well, that's fine. We'll compile those 3 other ones. Oh, look, these 3 other ones require 10 more packages for 32-bit, right? Okay, we'll do those. We'll do that. And once we got to about 150, we were like, wait a minute. We're compiling everything. and yeah, that's the conclusion. And, really the conclusion that CentOS before us came to is in order to build these 32-bit packages, these few, we effectively have to build 32-bit for everything. And it's I'm not going to go into it right now, but if you connect to the Peridot DNF repo, or we build 8 and Koji still, the Koji repos, the 32-bit packages for literally everything that's supported are in there. There are some packages, I think Firefox comes to mind, that will actually refuse to build with 32-bit. They're intentionally excluded, but most of them are there. And so, yeah, there was it was a sad realization. We thought it was going to be super easy to throw these 20 32-bit packages in, and then we found out, we did a couple days of building, and we're like, oh god, there's the dependencies of dependencies of dependencies. We have to build, we might as well build everything. And so we did.
Do you do a
It's more
32-bit
convenient.
kernel also, or is that
No, that's one of the
beyond the line?
packages that is
Yeah.
not, that excludes 32-bit, and that's a big reason why we don't have a 32-bit ISO.
Right.
It would be hypothetically, this project idea for anybody who really wants a 32-bit system, you could take the 32-bit builds that we've done for all of user space and figure out a way to build a compatible 32-bit kernel, package, put them together and produce an ISO or an image or something. And I don't see what reason why it wouldn't work. It's a lot of work though. I'm not sure.
Yeah.
I'm not sure it's worth it. Any 32-bit, old hardware aficionados out there, it's becoming increasingly irrelevant, I'm afraid. So it's just not something we're interested in doing.
Sure. So the last big thing that we haven't really touched on in terms of things that kind of cross the boundary and aren't part of the isolation is the kernel itself. So even though it's a container, presumably, as I understand, when you're running mock, you're doing the build with the kernel of the host system, no matter what you're targeting. Has
Yes,
that ever
exactly.
come up? Is that an issue?
Yes.
Okay.
Usually in ways you maybe wouldn't think about, right? So, good example is during the Rocky Linux 9 building. I believe there was a Ruby package that it required. Back up in at the time, and I think even still now, we're building Rocky Linux 9 on Rocky Linux 8 systems, right? So these have, they're running containers, but they have a Rocky Linux 8 kernel. It's a little older, but still well supported. And there is a Ruby package, I can't remember which one, but it's related to Ruby, that for its compilation, it requires it runs some testing, and it requires a kernel to support. I think it's not only tempfs, the temporary file system feature, which we have in our Rocky 8 kernel, but there's a certain feature of tempfs called like O_temp, and I think it's for, I can't remember exactly the feature it provides, but it's a new thing in the 9 kernel, and the Ruby tests would not pass. The tests are done at the end of compilation for an RPM, make sure the binaries you produced are working properly. And yeah, we ran into a problem. We actually, in order to make sure everything was okay, I believe we had to, for a couple of our build machines, we had to upgrade the kernel on them so that it would support this new tempfs feature. And that's just an example of how that can come up.
Have you ever encountered a situation where it works in the other direction, where you have a newer kernel, but something you're trying to build requires an older one?
My memory is very fuzzy on this. I want to say yes, but I don't have a specific example in mind, because God knows, we've run into an awful lot of problems like that we've had to investigate and
It's
fix.
just, if the question is, has a problem occurred, then the answer is almost certainly yes, at least once.
We've broken things in so many ways, you make your head spin. But again, that's usually, people are like, oh, it's so easy. You're just calling these RPM builds over and over again. And well, yes, and if all of them completed on the first try,
Mhm.
then yeah, my job would be simple. And I'm very I'm happy to give it up to anybody who wants to do it. But the problem is when things don't go right, and you'll have to spend, in some cases hours, in some cases days, trying to figure out, hey, why the heck won't this work, and why did it work before? And there's a lot that goes into that. Oftentimes, it has to do with, again, the versions of things that you're bringing in and building against, because they, sometimes a new version comes out and it will break at build time. It will break something in an unexpected way.
Yep.
So it's very.
How did this ever work before is the worst question in systems engineering.
comes up more than you would think in RPM building. Yes, especially again, this is building in mock here is great if you want to build, 2 or 3, 4 or 5 packages. But when we're talking about, industrial capacity and we need to build, 5,000 packages or whatever, stuff like this comes in handy, right? We can do mass builds and we say, hey, we're not going to do this one at a time. We're going to, kick off a million or whatever. Right?
So, Skip, are you running across users out there that are trying to take some of these packages that are just the default, do something to them, and then, like you said earlier, put them into their own repos so they have something specific that's required for their company, their environment?
That brings me to another great point, is that I mentioned that we already know that we can get our source RPMs from our download site, or again, they're available via DNF command, right? If you check out your inside of, yum.repos.d, here it is. Rocky Linux and other distros come with source repositories, and all they do is point to these source RPMs. However, these source RPMs have to come from somewhere, right? And I'm just going to go into that real quick. Git.rockylinux.org. We want to put that up on the screen. It's another great site. I'm here a lot, quite frankly. And so let's go into staging, RPMs, and then the source RPM name. So let's talk about bash here, right? And it's my fault, I misspelled it. Typo. Staging RPMs bash without an apostrophe at the end. And you'll see here we got some branches, and branches are funny when it comes to distros here. This is Rocky 8, Rocky 9. We never merge branches really. These are just the different versions that we keep track of. And you can see, when things were imported. I think the latest version of bash for Rocky 9 was imported 5 months ago and built. And I think there hasn't been any updates from Red Hat since then. But you'll notice here, sources and specs. Let me pull up my old, if you remember this guy here, this is the source RPM that we got from here. And if you browse it, this source here, I'm going to put it on top here so that we can kind of see them side by side. You'll notice, so specs, bash.spec is right up here. And if you go into sources here, you'll see all these patch files. And here they are here. They should match exactly, right? And that's where you want to know where these source RPMs come from. Check this out, right? And this is open to everybody. You can clone it. You can muck with it. You can do whatever you want with it. And you can build your own. You can, don't want our bash, build, make your own, fix bash. Put your own patches or whatever in. And so this is, and our sources in turn come from git.centos.org, which is where Red Hat publishes their official source code for, and we'll see, go into branches here. Just like us, they have CentOS branches. You want the CentOS 4 bash, here it is. All right. We're not really interested in that. We'll check out. There is no CentOS 9 really, but they still call it C9. But yeah, this is the Red Hat source code, and this is exactly where we got it. It gets pulled down and tagged into our Git here. So you can kind of see the flow of where these things come from. And if you're interested in modifying it, it's pretty easy. Well, I won't say it's easy. I'm no C programmer, right? But it's it's easy to get at anyway.
Let's see, we're getting some. Oh, as I was posting, never mind. Thought we had a question.
Sorry,
Nope, no question. I thought we had a question, but I was.
We had a question. Okay, all right, good stuff. Yeah, so let me check my notes over here real quick. But I think that's about what I wanted to cover. Just please, if you're building RPMs, please consider mock. The old, especially if you're trying to use just plain old RPM build. It's hard and it's outdated, and I used to hate doing this. When my company back in the day would be like, "Oh, Skip, we need a customized RPM build for such and such a program." I'm like, "Oh no." All right, give me a day and I'll see if I can figure it out. Like this mock makes this much much smoother, right? We've kind of mock has done for package building, and especially RPM package building, what really containers have kind of done for developers. We have a standardized base that we can build on, and we can make sure that when I build a package in my mock, it's going to be the same as a package built in Jonathan's mock and Zane's mock. And as long as our configurations are the same, we should get the same result. And it's really excellent for that. So please consider it if you're still using raw RPM build to build packages. Nobody should be doing that because it's rough, like, quite frankly.
Never have to configure RPM macros ever again.
Yes, I'm not saying that, but for most things, yes. And configuring RPM macros are just configuring mock, right? Like, it's inside that mock configuration file. You can set macros just like you can do everything else, and so it's much easier than having to muck about on your file system with God knows where for wherever RPM macros are kept, right?
Oh, that's great. I don't think we have any more questions, guys. I really appreciate you coming on, Skip. Thanks for putting this together. It's great to see.
Good stuff.
Glad to see that there's easier ways to do this than
I'm glad it went well, because I don't. Whenever I do demos, things fall apart. It's
not today. It's been great. We really appreciate it. Appreciate it. So if I don't have anything else, I don't see any other questions. I really appreciate you joining. Join us next week and like and subscribe. We appreciate it.
Yep.
See you next week.
All right. Thanks, guys.